Now we're going to look at the IRT plot for this data. Okay, as you can see, I've selected all the items and moved them over. And what we're going to do first is just look at the characteristic curve. We're going to run it. The item characteristic curve is the basic building block of item response theory. All the other constructs of the theory depend upon this curve. Therefore, considerable attention will be devoted to this curve and its role within the theory. There are two technical properties of an item characteristic curve that are used to describe it. The first is the difficulty of an item. Under item response theory, the difficulty of an item describes where the item functions along the ability scale. For example, an easy item functions among the low ability examinees, and a hard item functions among the high ability examinees. Thus, difficulty is a location index. The second technical property is discrimination, which describes how well an item can differentiate between examinees having abilities below the item location and those having abilities above the item location. This property essentially reflects the steepness of the item characteristic curve in its middle section. The steeper the curve, the better the item can discriminate. The flatter the curve, the less the item is able to discriminate, since the probability of the correct response at low ability level is nearly the same as it is at the high ability levels. Using these two descriptors, one can describe the general form of the item characteristic curve. These descriptors are also used to discuss the technical properties of an item. It should be noted that these two properties say nothing about whether the item really measures some facet of the underlying ability or not. That is a question of validity. These two properties simply describe the form of the item characteristic curve. So, characteristic curves are useful tools for illustrating the relationship between the probability of a response and personability, but there is another function that describes the quality of measurement more directly. The item information function describes an item's contribution to measurement of personability such that the greater the amount of information, the more precision there is in estimating the personability. Item information is neither a linear function nor uniform in nature. It is shaped like an anthill. So here we go. So here's the item characteristic curve, and here is the item function. As such, item information is large at one part of the scale and small at the others. A Roche model item contributes maximum information at ability values that equal item difficulty. This relationship is illustrated here. So if you look here, the item in this item 9 has a difficulty level of 0.04, and the information function reaches its peak when the ability level is 0.04. And this means that this provides the best measurement of people with an ability level of 0.04. It also provides useful information for examinees with abilities between -1 and 1. So outside -1 and 1, it doesn't really contribute much to measurement of the latent trait. Additional items are needed to improve measurement precision at other parts of the scale. Item information functions combine in a simple way to summarize measurement precision for an entire test. Specifically, the test information function is the sum of item information functions. So I'm going to show you how we get this. I'll click off of it. Whoops. And now I'm going to go to Graph, IRT Plot, all this here, and now you want to click the item information function, and we're going to run that. There you go, and you see this.